All right, let's move on. Um, this is actually example 5 and not 7. So let's move on. Um, we have a radioactive substance that decays at an annual rate of 13%. That means at annual rate means per year. So if you set the equation, it's going to be your F is going to be equal to some A or P, whatever. Let's call it P1 plus I to the power N. Because this is per year. So it's going to be, in this case, you're using, so let's use T, time. Now, since it is decaying, they say it decays, that means it goes down. So that I will be negative. So it's going to be P outside 1 minus whatever I or R they give us, R to the power T. And that will be equal to your F, the future value, whatever is left. So I wanted to kind of write what we expect it to look like so you can use this also as a learning exercise. So they're saying that our f of t, this is f of t, what we have left will be equal to substance is the initial amount, which is 325, times uh, is decay at 13%. That means it's going to be 1 minus 0.13 to the power t. This is all, and then you just come to simplify this as 325, and then this is going to be 0.87 to the power t, and this is f of t. This is how this will look like. This is your final. So the f of t, that is the future value, which will be whenever, if I'm talking of tomorrow, tomorrow's value, which is t, will be equal to 1 if it is 1 year from now, is tomorrow. 1 day from now, whatever t is starting with the initial value. This is the decay factor times t, and then t will be whatever you plug in. So if t is 1 year, you plug 1 year here. So let's come back and check which of the following functions help model the remaining amount of the substance in gram t years later. Remain, obviously the answer is this. So you go back here, look at this one, 325.87 t. That looks correct. Let's come back here, 325. It can be this one because this here is not taking into consideration this one here. This is always the key. So this is wrong. 0.87 is not your starting value. So this is wrong. 0.13 is not your starting value. So they kind of trying to pull your legs by giving all these stupid answers. But here your best choice is answer A. And that is how you solve these nonlinear problems.